in the electric circuits, in our regular circuit, whenever we want to allow current in only one direction, we use a diode. So current will go from anode to cathode nicely. Whenever current, some other current is trying back to this circuit, we have two
Like
circuits.
AC.
There is one circuit here, there is one circuit here. So we want to allow current from this circuit to that circuit. Okay, fine. But we should not allow current from that circuit to this circuit. Then we use this diode. So this is a regular diode what I am talking about. Tomorrow's project you have a diode, day after tomorrow you have another diode. But today's project you have only light emitting diodes, no other diodes. They are called silicon diodes. Silicon diodes are not there today's project. But actually your light emitting diodes will follow the same function of this diode. But however, great principle behind is whenever current is passing through the LED, light comes up. What comes up?
Light.
This is the greatest, funniest part of this diode is that three different colors are there, no?
Red, green,
So
yellow.
take any of the color LED, light emitting diode. Whenever there is a current flowing through the diode, what is it coming out of the diode junction? From the center of the diode junction? Light rays are coming out. That's where you are enjoying. Now the greatest, toughest question to you all. Okay. Very interesting, toughest question, my dear friends. What happened? This guy first time he came to me, this small guy. What he did, you know, my dear friend? Every day he come to me and he will ask me, sir, give me one LED, sir. One LED, sir. One LED, sir. I'll keep on giving. Whenever children ask me, I can't, I can't avoid that. I like children. So every day he is coming and taking one LED. In his language LED. After 5 days he asked me, what are the LEDs you are doing? Are you eating these LEDs? What is that you are doing? Then you know, sir, every day I wanted to come back immediately because the moment I go home, I connect to battery, 9 volt battery, and immediately they just glow, sir. But after 1 second they don't glow, sir. So if I come back immediately, then you don't give. That's why I'm waiting for a day to come, sir. So next day you will forget it. Then I will ask you one more and you will give me. So this is what you are doing and taking and connecting and then losing the LEDs. Then finally I laughed at him so much. Oh my goodness, you have told me this issue the first day itself. Oh, anyway, why is that? And he also asked me another question. Saying that, sir, the same LED, if I am connecting it to 1.5 volt battery, nothing is happening, sir. It's comfortably glowing, sir. Nothing is happening. Happy about it. But when I am connecting it 9 volt battery, immediately it's going off, sir. After that, it's never going in, sir. This is the question he came to me 5 months back. Tell me, my dear friends, how many of you can answer this question? Why is that? Yes, tell me.
So because the capacity that LED can hold is lesser than 9 volts, it can hold up to 2 volts or 1.5 volts.
Yes, good. He is telling good answer, but he is telling capacity and volts. But here onwards, all my students must talk about power. So when you wanted to talk about power rating of the LED or anything, then definitely you can't only talk about voltage, because power is nothing but product of voltage. It is not voltage alone. My dear friend, that is okay, keep remember about this point, okay? So now I am going to introduce about the current component about this particular LEDs. This is very important area. You have to understand this, okay? Shall I talk about the current component of the LED? Okay, now I have a LED here. Light emitting diode. So whenever this small little arm connects this LED anode and cathode to 1.5 volt battery, the small pencil is there. No? Here is the plus, here is minus. Whenever he is connecting to this 1.5 volt battery, what's happening? Because this LED is also made to work at 1.5 volt, so that no problem. The LED is just allowing the current in the LED somewhere between 10 to 20 milliampere. 10 to 20 milliampere. That means LEDs are made in such a way that the minimum brightness is at 10 milliampere, and if you want more bright, maximum current you can allow through the LED to the maximum of 20 milliampere, for example. Okay, my dear friends? So that is okay. At 1.5 volts full new battery, brand new full battery, then fine. It's good that 20 milliampere is going. And then at 1 volt, maybe 10 milliampere. Below 1 volt, when the current in the LED is falling down less than 10 milliampere, the brightness may not be coming out. Though the current is going inside the junction, you might not see the light rays coming out. Yes or no? Similarly, I will tell you, for 100 watts bulb or your bike bulb, whatever bulb you take, when you give full voltage, it gives full light. If you keep reducing the voltage, you see the filament is red. After that, you further reduce the voltage, then you don't see the filament is red. It doesn't mean the current is not flowing. Still the current is flowing. But however, you don't even see the filament is hot. Because that much less current is going in the filament. Okay, that means you need a little higher currents for make the filaments bright. Further, more bright means more current has to flow. Similarly, here in the LED thing also, they may give you the required light rays output at 20 milliamperes. So right from 10 milliamperes current onwards to 20 milliampere currents, fine, you are fine with that. Without knowing much difference in the light intensity, you will enjoy that. Okay, my dear friends, but what happens, what this little L did? So, he just replaced, because after that, because in my home I don't have much of this 1.5 volt batteries. I don't work much with them because they are little, okay? So, I always want to design every of my projects for children only at 9 volt because 9 volt batteries are everywhere available these days.
Yes,
and
sir.
also that has got little potential so that I can make other lot of components to work. 1.5 volts means very less voltage. Only few components I can make work, all rest not rest of all. So here these days this boy what is doing? So 9 volt battery has got one plus and one minus, right? Yes or no? So what is that he is doing? He is connecting networks. What is that he is doing? He is connecting directly 9 volt battery to LED. Then what is happening? Because the LEDs are no, in the taps also the same thing, no? Similarly, when current is more in the LED, more brightness. Because of more brightness, more current, the junction got so much heated up inside. Out of rated capacity of the LED. Then what's happening? The junction is permanently getting open. After that it is open circuit, it is no more connected. So this is semiconductor, when it is acting as semiconductor, it is allowing little current, output is, result is light rays coming out. But when it is open, it is not allowing any more current to flow in the circuit. After that the LED is no more functional, no more working. It is permanently damaged, that he didn't know. He only coming back, sir, no more LEDs. So 5 days he came like that. After 5 days I asked him, what is this every day you come and take one LED? Then he told, I don't know, sir. I just connect to my 9 volt plus minus, sir. Only it comes once, sir. After that it doesn't come, sir. Just imagine what is his question. So look at him, how he is looking. So interesting, no? Now I'll ask him in Telugu, because after that he came to know and explained him and he learned about it. 1.5 volt battery ki LED పెడితే ఏమవుతుంది? బాగుంది. సో 9 volt బ్యాటరీకి LED పెడితే ఏమవుతాయి? ఎందుకని ఒకసారి ఎలిగి ఆగిపోతాయి. ఆన్సర్ చేయి. సో అట్లానే మీకు గుర్తుపెట్టుకోండి, మీ స్కూటర్ బల్బుకి మన ఇంట్లో 220 వోల్ట్ తీస్తే ఏమవుతుంది? ఎలవోల్ట్ బల్బులకి బ్లాస్ట్ అవుతాయి. అట్లా చిన్నప్పుడు నాకు తెలియక ట్రైన్లో బల్బు పెట్టుకొని ఇంట్లో పెట్టేవాడు. సో టామ్ అని వెళ్తా ఉండేవి. సో ఆ ఎందుకు వెళ్తారని రీసెర్చ్ చేస్తే అర్థమైంది, అది 110 volts డిజైన్ చేశారు. సో మన ఇంట్లో 220 volts ఉంది. మరి అప్పుడు హౌ టు మేక్ దమ్ వర్క్?
Resistors.
No, I'm a common sense person. So at that time I decided, okay, now in that case, 2 120s becomes 220. Mathematics, man. So what I did is, this is one bulb, and connected in series. This is one bulb, this is one bulb. This is my phase notal, 220 volts. So 220. So 120 is dropped here, another 120 is dropped here. So ultimately 220 volts, these two became in series and yes, this is also fully equal. This is also fully glowing, but ultimately I don't have to use any other resistor. So instead of stealing one, start stealing two. Yes or no? Sammy, yes or no? Do always this kind of things, okay? Okay, anyway, good. Happy? Similarly, for 9-volt battery also, if you keep 4 LEDs in series, don't have to use resistance. But I taught him how to use LED with resistance. Okay, man? Yes or no? Now, how can we make sure LEDs start working at 9 volt? That is what is my interesting question. I specially organized this camp to explain this kind of critical points, which were not really explained in many other books, teachers or anywhere. Okay, man, this is the way. See, now I have 9-volt battery and I have LED. And the moment I switch on the LED, and my LED should not blow off, what I need to do? I need to put one resistor in between. Yes or no? I need to put one resistor between the circuit. Okay. Yes or no? So now whenever I switch on, the current starts flowing in this loop and it should not be more than 20 milliampere. How do I control the current? What is that I told you? The function of resistance is what?
To oppose the flow.
To oppose the flow of electrons. So that current can be controlled. So I don't want to allow the current in this loop more than 20 milliampere. So how do I do? Introducing a resistor here. So what happens? I will design the value of the resistor in such a way that it will not allow more than the current. Or, as we know the designed voltage for LED, Mr. What is your name? Huh? Ruthik, you told me. What is the operating voltage of LED? You told me?
1.5 volt to 2 volts.
Suppose say 2 volts. The operating voltage of LEDs, they designed made the LEDs to work at 2 volts. And what is the voltage we have?
9 volts.
And what is the voltage we need to drop so that we get only 2 volts here?
7 volts.
7 volts. So we need to drop here 7 volts. So to drop the 7 volt and the required current in the LED 20 milliampere, what is the resistor value we need to put here?
0.1.
No, listen. The required voltage to be dropped here 7 volts and required current to go through this LED to give you the maximum bright is 20 milliampere. And what is the value of what is Ohm's law? R is equal to
R is equal to V by
V by
I.
Now what is the V you need to drop?
7 volts.
And what is the current you need to allow in the LED?
20
Milliamperes. Now 7 by 20 milliampere, whatever value of resistance comes, that is your value to be put there.
What is the value, sir?
You do it math, don't ask me.
0.35.
Huh?
0.35.
0.35? Check it out. Okay, you need to calculate right now. R is equal to 7 by 20 milliamp, you know, 10 raised to minus 3.
Minus 3.
And if you take it up,
7 into 10 or 3 by
what is the value it is coming up?
700 by.
So you calculate the value and it's supposed to be here somewhere for 9-volt battery around 390 ohms to 470 ohms in between. Okay? Or even up to 1K, 1.2K also you can minimize because I designed in this circuit 1 kilo. Why? Because at 1 kilo the brightness is reduced but the battery comes for more time. Okay, then you finish it off, calculate the value and then you can have